Hello again. In this video, we're still working with operations with complex numbers, and we're going to do division. It says divide and write your answer in the form a plus bi. For the first example, I need to explain that when we divide, we are not allowed to have imaginary or complex numbers in the denominator. So we need to get rid of these i's in the denominator. In this first example, I have I. In the second example, I have the whole complex number. But in both examples, we're going to use the same strategy to get rid of I. What we do for example 1 is we multiply the top, or the numerator, and the denominator by the conjugate of the denominator. So what is the conjugate of the denominator? Let me give you an example. If you have the complex number 3 plus 5i, the conjugate will be 3 minus 5i. If you have the complex number 4 minus 2i, its conjugate is 4 plus 2i. Notice that when we do conjugates, we keep the same exact real part, and what changes is the sign of the imaginary part. Here, notice we kept the real part exactly the same as the original, but what changed was the sign in front of the imaginary part. So when I have this number, for example, 7, and I ask you for the conjugate of 7, your answer should be 7. Why? Because the conjugate of a number will only affect the imaginary part. And since 7 doesn't have an imaginary part, then the conjugate of 7 is 7, because when we do conjugates, the real parts stay exactly the same. You can also think that 7 can be rewritten as 7 plus 0i, which means no imaginary part. And then when asked for the conjugate, you could say it's 7 minus 0i, which would equal 7. So the answer would be the same. Same thing happens when you have 3i. If I ask you for the conjugate of 3i, your answer should be negative 3i, because we know that the conjugate only affects the imaginary part by changing the sign in front of it. So when I only have the imaginary part with no real part, the conjugate will be the opposite sign. You could rewrite 3i as 0 plus 3i, where 0 becomes the real part. And when asked for the conjugate, you can say it's 0 minus 3i, which is negative 3i. So that's why the conjugate of 3i is negative 3i, and this is why the conjugate of 7 is just that same 7. Knowing the explanation of the conjugate, now I'm going to use the conjugate to get rid of the imaginary number in the denominator, which is not allowed. So the conjugate of I would be negative I. So I'm going to multiply the numerator and the denominator by negative I. We're going to use the distributive property. So that means I'm going to take this whole thing and I'm going to multiply it by negative I. So negative I times 2, that's going to equal negative 2i. And negative I times negative 3i, that's going to be positive 3. And remember, I times I is I squared. In the denominator, I'm going to have negative I times I, and that will give you negative I squared. Now we simplify the numerator and denominator. So I'm going to rewrite negative 2i plus 3, and remember that I squared is equal to negative 1, over negative I squared, and remember I squared is negative 1. So in the numerator, I end up with negative 2i minus 3, and in the denominator, I end up with a positive 1. Remember, we need to write our answer in the form a plus bi, where the real part goes in front. So I'm going to rearrange the terms, negative 3 minus 2i, and that's your final answer. For the second example, we're going to do the same thing we did with the first example. We are going to multiply the numerator and the denominator by the conjugate of the denominator. So I have negative 1 minus 5i. I'm going to multiply. Remember, the real part stays exactly the same, and what's going to change is the sign of the imaginary part. So the conjugate is negative 1 plus 5i. And I multiply both the numerator and denominator by negative 1 plus 5i. In this case, I'm going to have to use FOIL because I have 2 terms times 2 terms. So I'm going to have to do FOIL twice, in the numerator and in the denominator. So let's go ahead. I'm going to start with 5 times negative 1. That's going to give you negative 5. And then I'm going to do 5 times 5i. That's going to give you positive 25i. And then I'm going to do negative 2, this piece here, times negative 1. That's going to give you positive 2i. And then you're going to do negative 2i times positive 5i, and that's going to give you negative 10i squared. We're done with the numerator. Now I'm going to go down to the denominator and do FOIL again. So I'm going to grab negative 1 and I'm going to multiply by negative 1. That's going to give you positive 1. Negative 1 times positive 5i, that's going to give you negative 5i. Then I'm going to grab negative 5i, this whole thing here, times negative 1, that's going to give you positive 5i. And then negative 5i times positive 5i, that's going to give you negative 25i squared. Okay, I'm done doing FOIL. Now I'm going to simplify the numerator and simplify the denominator. And this is what we get. In the numerator, the first thing I'm going to do is I'm going to change this I squared to negative 1. I'm going to do the same thing in the denominator. There it is. Now I'm going to start calculating negative 10 times negative 1. This becomes plus 10. And negative 25 times negative 1, that becomes plus 25. I've rewritten my expression. I've multiplied negative 10 and negative 1, and I got positive 10. And I multiplied negative 25 times negative 1, and I got positive 25. Now I'm ready to combine the like terms. I'm going to grab the real parts, and I'm going to add them together. And then I'm going to grab the imaginary parts and add them together. So for my numerator, I end up with negative 5 plus 10. That's going to give you 5. In the denominator, my real parts are going to give me 26. My imaginary parts, I'm going to grab 25i plus 2 i's. That's going to give you 27 i's positive. And in the denominator, your negative 5i plus 5i, that's going to give you 0 i's. So you're going to get 26, and that's it. And this is your final answer. Make sure that the real part is in front, the imaginary part is in the back. Let's square this answer off. There you have it. I hope you understood. I'll see you in the next video.